servicing aircraft air, nitrogen, oil, and fluids. Now, checking or topping up fluids in an aircraft, it's a big deal in maintenance. But before you even think about it, you got to check the specific aircraft manual for the right tools and steps. For engine oil, it's usually checked with a dipstick or a sight gauge. Marks on the stick or gauge show the correct level. For piston engines, check it after it's been idle. Turbine engines, right after shutdown. Oh, and here's a tricky bit. Some dry sump systems hide oil in the gear case, not showing up on the dipstick until the engine's running. If you top it up before that, it's going to overflow. No bueno. Never, and I mean never, overfill the oil tank. That stuff foams up when it's churned around the engine. And guess what? The tank's got space for that foam. Always use the right oil for the right engine. No mix and match here. Now, when it comes to hydraulic fluid, fuel, or oil spills, get that off your clothes or skin pronto. Fire hazard and health risks, you know? When you're working on a hydraulic reservoir, use the correct fluid. Usually, the container or its color tells you what's what. Some reservoirs are pressurized by air, so bleed that air off before you start servicing. And hey, contamination during servicing, big no-no. Also, when changing hydraulic filters, make sure the pressure's off the system first. After swapping filters or messing with the fluid levels, purge the air and check for leaks. Now here's the kicker. When you're filling up tires or struts with high-pressure nitrogen, be super careful. Clean the area before connecting the hose, and for the love of aviation, don't overinflate. Ground support equipment. Electric ground power units. Now these electrical units come in different shapes and sizes. Some towed, others stationary, and some can even move on their own. Some are for hangar use during maintenance, while others are for the flight line, either at a gate or towed between planes. The stationary ones usually get power from the facility, but the movable units often have an engine on board that cranks a generator for power. Smaller ones might use batteries and are handy for starting light aircraft. The bigger ones, well, they've got generators, offering a range of power for starting engines, turbine or reciprocating. But here's the catch with the large towed ones. They're a bit top-heavy, so they're towed carefully and no sharp turns allowed. Picture shown in figure. Now, self-propelled units are pricier but offer more varied output voltages and frequencies. There's also the stationary power unit, as seen in figure. It is providing DC power and even 115 200-volt, 3-phase, 400-cycle AC power for a short while. Safety tip time. When using these units, position them carefully to avoid bumping into aircraft if the brakes fail. And when you're connected to an aircraft or when the generator's running, never ever move that power unit. Remember safety first when dealing with aircraft electricity. That wraps up the basics of ground electrical units for aircraft maintenance. Hydraulic ground power units. Shifting our focus to hydraulic ground power units, or hydraulic mules, these portable test stands come in various sizes and serve a critical role in aircraft maintenance. Think of them as providing hydraulic pressure for tasks like draining and filtering hydraulic fluid, refilling systems, and checking for leaks. They operate at pressures of 3,000 psi or more, demanding extreme caution. The units are electrically powered and capable of delivering variable fluid volumes. Figure gives you a visual representation of a portable hydraulic power unit. Ground support air units. Now let's talk about air carts. These are essential for providing low-pressure, high-volume air up to 50 psi, used for starting engines and regulating aircraft temperature on the ground. Air carts often house an APU that supplies bleed air from the compressor for various aircraft functions and engine starts. Visualize this by referring to figure. Ground air heating and air conditioning. Lastly, let's touch on ground air heating and air conditioning. Airport gates typically have permanent installations that offer heated or cooled air, connecting to the aircraft's ventilation system using large hoses. Additionally, portable heating and air conditioning units can be positioned near the aircraft, connecting via a duct to maintain a comfortable cabin temperature. Oxygen servicing equipment. Now let's discuss the critical topic of oxygen servicing equipment for aircraft. Before proceeding with any servicing, it's paramount to refer to the specific aircraft maintenance manual to identify the appropriate servicing equipment. When dealing with gaseous oxygen, a two-person team is required. One person oversees the control valves of the servicing equipment, while the other observes the pressure in the aircraft system. Continuous communication between the two is vital, especially in emergencies. Safety precautions. It's crucial to note that oxygen servicing should never occur during fueling, defueling, or any other maintenance activities that could pose an ignition risk. All oxygen servicing of aircraft must be conducted outside hangars. Types of oxygen. Aircraft commonly use two types of oxygen, gaseous and liquid. Gaseous oxygen is stored in large steel cylinders, while liquid oxygen, often referred to as LOX, is stored and converted into a usable gas through a liquid oxygen converter. Types of commercial oxygen. Oxygen available commercially falls into three general categories: aviators breathing, industrial, and medical. Aircraft breathing oxygen systems must strictly use oxygen marked as aviators breathing oxygen, meeting Federal Specification BB0925A Grade A or its equivalent. Industrial oxygen may contain impurities harmful to occupants, and medical oxygen, although pure, may freeze at high altitudes where oxygen is necessary. Oxygen hazards. While gaseous oxygen is chemically stable and non-flammable, it accelerates combustion and forms explosive mixtures with oil, grease, or bituminous materials. Physical damage or failure of oxygen containers, valves, or plumbing can lead to explosive ruptures. Therefore, maintaining the highest standard of cleanliness and allowing only qualified personnel to service aircraft gaseous oxygen systems is imperative. Additionally, liquid oxygen, due to its low temperature, causes severe burns or frostbite upon skin contact. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download one of ebooks. However, each individual